Hello, ladies and gentlemen. My name is Valeria, and as a coach of the systems team, I'm very glad to introduce our today's presentation. But before, I'd like to thank our customers, Dr. Stefan Ferkles from T-Systems and Dr. Raman Tandon from VWeb, and our project leader, Konstantin Scheumann. Our project, Chess 2.0, is the continuation of the project from last semester. And as the previous time, we are focusing on humans who operate in a dangerous environments. And I think we are ready now. Show along. Julia, the stage is yours.
Yes. Thank you, Valeria, for this kind introduction. We should not lose no time and get right into it. So, if I ask you, what do you see on this picture? Probably most of you would say a firefighter. Some of you might say, this is a picture from the last semester. What I see is a brave man with a family like you and me. A man who decided to put his life to risk to save others. Other people that he doesn't even know. We as a team developed a system to help these lifesavers. We analyzed current IT systems and concluded that most of them are very technology-oriented. And also, they are not intuitive to use. There's no possibility to enable real-time health monitoring. We found that there's potential to increase operational safety. So what we do is we developed a human-centric cyber-physical system which excels current communication systems and enable real-time health monitoring at the same time. So, who are we addressing? Of course, we are addressing the mission participants who operates under continuous danger and under high pressure. Also, we are addressing the commander. The commander is responsible for the overall mission success and operational safety. He is the one giving instructions. The medical advisor monitors the participant regarding the current condition and also advises the mission commander and communicates with the participants. So the mission participant is the center of our system. Each mission has multiple mission participants and one commander and one medical advisor. Each mission participant wears a protective suit with textile integrated sensors with which measures health data such as heart rate, humidity, and various temperature values. We also included a medical card. The medical card includes historical mission data, which enables the medical advisor to make even more precise diagnosis during the mission. We included two report and request devices and one smartwatch in the protective suit. This way, we enabled a new intuitive human-centric interaction channel between the mission participant and the mission control. The mission participant has these report devices which can be triggered individually and a smartwatch which can receive advices and instructions from the mission control. Mission control, therefore, here commander and medical advisor can interact and communicate with the mission participant using dedicated interfaces. So let's get to our top-level design. We have the report devices and the health data reader, which sends health data and participant requests and responses directly to the mission control. The mission control system then distributes this information directly to the commanders and the medical advisor UI. The medical advisor and the commander are able to exchange advices and instructions over the mission control system directly to the participant.
So, now that you got an overview of our system, we want to dive deeper into our data flows. So first, our data is gathered in our health data collector, And it's, as Shulong said, heart rate, humidity, and temperature all gathered together and sent to the data collector. This data collector then sends it through the data manager to our message service. From there, the data is distributed to both the UIs, the Commander UI and the Medical Advisor UI, and also stored in the data repository. From there, it can be accessed from both UIs as historical data and helps the medical advisor with his advices. So on the side of the mission participant, we have those two input devices and also an instruction receiver. The commander is now able to send commands to the mission participant, and the mission participant receives them on his instruction receiver. And same for the medical advisor, he can send retreat messages through the data manager to our mission participant. The mission participant himself can send status updates and emergency requests to the commander. So let's see what technologies we are using. So on the mission participant side, we have as a data collector the health lab that is used on the International Space Station. We have as input devices two flick buttons, and we have an Apple Watch as instruction receiver. For the secure health data collector, we are using actually two devices. We have to do that due to iOS constraints because our health lab is communicating through Bluetooth Classic, and the buttons and the Apple Watch are communicating through Bluetooth Low Energy. So this is not possible to combine in one device. So it's here an iPhone and an iPod Touch. Our server and the two devices for the commander and the medical advisor are communicating all together through the MQTT protocol, and our historical data can be accessed through a REST API. So now that you got an overview, we want to show you our trailer. Enjoy. So thank you very much. So what we want to show you now is our textile integration. Ready? So we stitched two patches for our two emergency and status buttons, and we 3D printed the protection for them so that the buttons are not pressed by accident or when our participant falls down. Those patches are really easy attachable to our try-out suit, and they are easy accessible by the mission participant and easy clickable. So yeah, that's part of our textile integration. And for the client acceptance test, we want to show you our application Yes, thank you.
Yeah. Yes, thank you, Julia. Now we talked a lot about health monitoring. Let's talk about the current condition of our project. We finished the UI designs as well as the first versions of our textile integration. We set up an initial system infrastructure and enabled health data gathering. We partially implemented our UI and also established data visualization. But we're still not done yet. There's still a couple of things that we want to accomplish until the CIT. We want to develop an algorithm to enable health data analysis. Also, we want to establish a participant feedback channel as well as implement the Commander UI. And last but not least, we want to finish our medical advisor UI. A wise man once said, "One man can't whistle a symphony, it takes an orchestra to play it." And therefore, special thanks goes to our project management, our customers, and our consultants. But of course, also, special thanks goes to our team who put so much work and their time into this project. Now, we are at the end of our presentation, and are there any questions from our customer?
Yes, of course. So thank you for your presentation. We've heard a lot about medical stuff, and I'm not a technician, so could you please describe what's the difference between the current systems on the market and your development?
Thank you for the question. It's actually a very good one. Yeah. One thing that makes us unique is that we are context independent. We include context information. Also, we enable real-time health monitoring. And, Julia, sorry. Sorry, could you help me out here?
The health lab we are using is also really stable. There are no sensors out there that reliable, so that's, yeah, and I think
Yes.
that should answer the question, I hope.
Thank you.